Shown below is a hand sanitizer dispenser. In the space provided, draw a well-portioned freehand sketch. Now, well-portioned meaning it's not teeny tiny little thing, or that this is half the size of it, okay? So it should be looking reasonably like it is there. So it's got to be a freehand sketch, so no rulers, of the end view of the dispenser looking in the direction of the arrow. So you're asked to draw the end view. So what are you going to see? You've obviously got the slanted part here, you've got the straight part at the back, you've got this comes down to here, and then you've got
the end view, not the acceleration.
But you're told it's looking in from the arrow A. So it's telling you there from the direction of the arrow A. So that's why you're drawing that way there. Is that okay? Just be careful that there. It's not this one here. No. All right. The end view is looking in this way. You're not asked to sketch. You're not asked to do anything like that there. So just leave it. So 6 marks for getting that done. Okay. Shown below is the incomplete oblique drawing of the dispenser body without the logo. A 3D graphic is also shown, completely oblique of the dispenser. So, as we know, with oblique, everything is 45 degrees. Bringing these back at 45 degrees. 45 degrees. Doesn't say it's a sketch, so you can use your now whatever distance that is there, that's what we might do to the compass. Get that distance there. You want to keep, because you could have actually used sliding set squares either. Because those lines there would have to be parallel. Could use sliding set squares for that also. And don't forget about this little line down here in order to complete that there. And there are 10 marks going for that there. So the logo for the hand sanitizer dispenser is shown. It is based on a parabola, DOC. So DOC. Now, very important to highlight. Where is the vertex? There it is up there. Okay. That meaning that these lines are going to have to go towards the vertex. This here is our axis, meaning that these lines have to go parallel to our axis, okay? Redraw the parabola in the given rectangle ABCD. We're going to draw a line off here, any length, any angle, and one off here as well. And we're going to mark off with our compass a minimum, I'd say, of 4. 1, 2, 3, 4. Forget about everything beyond that line. 1, 2, 3, 4. It's this line that we're dividing into 4 equal parts. So this part is important. The 4 is important. So join those together, and then everything will go parallel through those lines. Remember what we said about up here? Because we've identified 0 is our apex, these lines have to go to that apex. You're going to do the same thing with this line up here. You might just want to shorten the distance on your compass a little bit. From A, you're going to mark out 1, 2, 3, 4. Forget about everything beyond that. 4, 1, 2, 3, 4. The 4th point here is going to join to 0. And then you're going to go parallel then through 3, 2, and 1. And like we said, these ones are going to have to go parallel to our axis. This is our axis here. So these ones are going to have to come straight down. So this one might come to the 1st point. This one's going to come to the 2nd one. And this one's going to come to the 3rd one. And that's going to give us our 3 points now on our parabola.
How should you divide the
Just be careful. It's just this line that we're dividing into 4 equal parts. And whatever we divide this line, we have to divide this line the same. So if we're dividing this into 4 equal parts, we have to divide this line into 4 equal parts. So once you get those points then, you draw on your curve. Try and keep it a nice curve at the top, not coming to a sharp point like that. Once you've 1/2 then done, you're simply going to bring those points straight across. You use axial symmetry, whatever distance they are this side of the line. You're going to rotate them around over to this side.
Sorry, I have that all closed off as well, by the way.
Right, the last part of this, complete the logo by constructing tangents from the point P. So we've got point P outside of the circle K. We're going to join that P to the center, and we're going to bisect that line. So from P, we're going to give it a name, let's say C for center. So from P to C, the center, you're going to bisect that line. Remember, mark above, below the line. Move the metal part of your compass up to C. Put the metal part of the compass into that center now and draw a semicircle. Actually, in this one, actually tangents on both sides. With a circle hits the arc, that's your point of contact. And the same over here, point of contact. Join that P to the point of contact. And there's your 2 tangents. So there's 6 marks going for the parabola and 6 marks going for the tangents, so 12 in total. Okay.